Hello everyone, welcome to Engineering Archives. Let us look at so this question says the pole is subjected to the force F, which has components Fx, which is equal to 1.5 kilonewtons, and Fz, which is equal to 1.25 kilonewtons. If beta is 75 degrees, determine the magnitude of the force F and Fy, which is its component along the y-axis. So first of all, they have given us the magnitude for this angle beta, which is equal to 75 degrees. And we need to find the value for two unknowns, which are the magnitude for the resultant force F and its component along the y-axis. So let's do the same procedure that we have been doing for the previous questions, and let's see how it works out. So first of all, let's find the components of the force F along each of the axes. So first of all, we will find its component in the x direction. So Fx is equal to, they have given us the value for the component along the x direction, and that is 1.5 kilonewtons. I'm going to write 1500 newtons. And this is also equal to the force F cos of the angle between the force F and the x-axis, which is alpha. Let's move on to the y component. The y component is equal to 1.25 kilonewtons, or 1250 newtons. It is also equal to the force F cos of the angle gamma. Sorry, this is not the y component, this is the z component. And finally, let's do the y component, which is the component that we have to find. So we don't have its value, but we can express this component as F cos of the angle beta, which is equal to 75 degrees. So now that we have all our components, we can just, now that we have all our components, we can express this as a Cartesian vector. So the force F is going to be equal to F of alpha I plus F cos of gamma J plus F cos of 75 degrees. Notice that in this equation we have 1, 2, 3, three different unknowns that are the force F, the angle alpha, and the angle gamma. But we can just replace this quantity by 1500 and this quantity by 1250, and that way we will be eliminating two unknowns. So let's do that. So instead of this, we can just write 1500 newtons, which is the x component, and 1250 newtons, which is the y component. Now all we have is just one unknown in the equation, which is F. So let's find the magnitude of the resultant force F using the resultant force formula. So that is going to be equal to, the magnitude of F is going to be equal to 1500 whole squared plus 1250 whole squared plus F cos of 75 whole squared. Taking square root of both sides, we get F squared is equal to 1500 1250 squared F cos of 75 squared. Subtracting F cos of 75 squared from both sides, we get squared minus F squared cos of 75 whole squared equal to whatever is on the other side. Now we can take F squared common, and we get 1 minus cos 75 whole squared equals to 1500 squared plus 1250. Now we can subtract 1 minus cos of 75 squared. We can divide that on both sides and we get 1 minus cos squared of 75. Divide both sides by 1 minus cos squared of 75. So this cancelled with this, and we are left with f equals to under root 15 100 squared plus 1 to 40 squared over 1 minus cos squared of 75. And the value that we get for f is equal to 2021 newtons. Now that we have the magnitude for f, we can find the magnitude for the component of f along the y-axis by using the cos rule. Since we have the angle between the force F and the y-axis, which is equal to 75 degrees, we can just use the cos rule and say 2021 cos of 75. And this would be equal to the y component, which is 523.2 meters. So this was the simple procedure for this question. All we had to do was just improvise a little bit, and everything just showed itself to us. Thank you very much. See you in the next video.